Nikola Tesla was born on July 10, 1856, in the village of Smiljan, in the Austrian Empire, now Croatia. His father, Milutin Tesla, was a Serbian Orthodox priest, while his mother, Juka Mandic, was the daughter of an Orthodox priest and was known for her mechanical and craft skills, although she could not read or write. Tesla was one of 5 children, including 3 sisters, Milka, Angelina, and Marika, and an older brother named Dane, who was killed in a horse riding accident when Tesla was 5. Tesla later wrote that he could be considered a true representative of Serbian virtue and humanity, and that he admired his brother and felt he could not live up to him. From an early age, Tesla demonstrated an imagination and a knack for making home-crafted inventions. As a boy, he was fascinated by the mysteries of nature and often saw the world through a lens of potential scientific discovery. He was particularly interested in electricity and had a desire to harness the power of Niagara Falls, which he would do later in his life. Tesla's education began at home, where he was taught basic reading, writing, and arithmetic by his mother and father. He was an extremely bright child who possessed a remarkable memory and a knack for solving problems. At age 7, he began formal schooling in German, arithmetic, and religion at the elementary school in Smiljan. In 1862, the Tesla family moved to Gospic, Croatia, where Nikola's father worked as a priest. In Gospic, Tesla completed his elementary education and continued his schooling in the so-called Higher Real Gymnasium in Karlovac. Tesla's father expected him to follow in his footsteps and become a priest, but Tesla's interests lay squarely in the sciences. After surviving a serious bout of cholera, Tesla convinced his father to let him study engineering. He enrolled at the Austrian Polytechnic in Graz, Austria, on a military frontier scholarship in 1875. In his first year, Tesla never missed a lecture, earned the highest grades possible, passed 9 exams, and even started a Serbian culture club. However, during his second year, Tesla came into conflict with a professor over the Gram dynamo, when Tesla suggested that commutators weren't necessary. Tesla's academic performance declined and he eventually left the school, never to return or receive grades for his last semester. He cut off all contact with his family to hide the fact that he dropped out. His friends even thought that he had drowned in the nearby Mura River. During this time, Tesla developed a passion for, and became very skilled at, playing billiards, chess, and card playing, sometimes spending more than 48 hours in a stretch at a gaming table. In 1880, Tesla moved to Budapest, where he worked at the Central Telegraph Office. Later, he was allocated to the Budapest Telephone Exchange. During his employment, Tesla made many practical improvements to the central station equipment and claimed to have perfected a telephone repeater or amplifier, which was never patented nor publicly described. In 1882, Tesla moved to Paris to work for the Continental Edison Company, and while there, he conceived the idea for the induction motor and began developing various devices that used rotating magnetic fields, the basis of most AC machinery. In 1884, Tesla emigrated to the United States to work directly for Thomas Edison, where he would eventually establish his career as an electrical engineer. Nikola Tesla arrived in New York City in 1884, with little more than the clothes on his back, and a letter of introduction to the famed inventor and businessman Thomas Edison, from Charles Batchelor, one of Edison's associates in Europe. The letter famously read, "I know 2 great men and you are one of them. The other is this young man." Tesla started working for Edison, tasked with improving the design of Edison's inefficient motor and generators. Despite Tesla making significant improvements, Edison did not honor a promised $50,000 payment, allegedly saying, "Tesla, you don't understand our American humor," which led to Tesla resigning. In 1885, Tesla received funding for the Tesla Electric Light Company and was tasked with developing improved arc lighting. After successfully doing so, however, Tesla was forced out of the venture and for a time had to work as a manual laborer in order to survive. In 1887, Tesla constructed the initial brushless alternating current induction motor, which he demonstrated to the American Institute of Electrical Engineers, now IEEE, in 1888. Following this, George Westinghouse, founder of the Westinghouse Electric and Manufacturing Company, bought the patent rights to Tesla's system of alternating current dynamos, transformers, and motors. Westinghouse used Tesla's alternating current system to light the world's Columbian Exposition at Chicago in 1893. Tesla's work shifted to the controversial and later discredited field of high-frequency alternating currents, which he used to develop inventions he thought would bring about a new industrial revolution. In 1891, he invented the Tesla Coil, which is still used in radio technology today. In 1893, Tesla worked with Westinghouse to illuminate the Chicago World's Fair, marking the first large-scale demonstration of alternating current for electrical power. Later, they won the contract to install the first electrical system at Niagara Falls, a huge achievement that demonstrated the superiority of alternating current over direct current, which was favored by Edison. In the late 1890s, Tesla worked on his idea of wireless transmission. He imagined a world where communication could happen wirelessly and worked to develop technology that could transmit power and data over large distances. His ambitious project of the Wardenclyffe Tower, funded by J.P. Morgan, aimed to transmit messages across the Atlantic to England and to ships at sea. However, Morgan ceased his funding before the project's completion, and the tower was dismantled in 1917. Despite the brilliance of his work, Tesla faced constant financial difficulties. He was not adept at business, and his ventures often cost more than what he earned. He spent his later years feeding pigeons in New York City and occasionally speaking to the press. The feud between Nikola Tesla and Thomas Edison, two of the greatest inventors of the 19th century, was largely the result of differing views, business practices, and the nature of the electrical systems each championed. Tesla began working for Edison shortly after arriving in the United States in 1884. Edison, who was already a well-established inventor and businessman, hired Tesla to work at his lab in Menlo Park, New Jersey. Edison was primarily invested in direct current, DC systems, whereas Tesla would later become a key advocate of alternating current, AC systems. One of the primary disputes between Tesla and Edison arose from their differing views on electricity. Edison believed that DC was the superior system, as it maintained a constant voltage and was better suited for residential use because it was less dangerous. Tesla, on the other hand, saw the potential in AC, which could change voltage depending on the power and distance required, making it more suitable for long-distance power transmission. A notorious incident occurred when Edison promised Tesla a sum of $50,000 if he could improve the efficiency of Edison's DC dynamos. Tesla succeeded in the task, but when he asked for the promised money, Edison refused to pay, stating that the offer had been made in jest. Feeling cheated, Tesla quit his job with Edison. This event marked the beginning of their rivalry, which escalated into the so-called War of the Currents in the late 1880s and early 1890s. Tesla, now working with Edison's business rival George Westinghouse, engaged in a public relations battle with Edison over the future of the electricity industry. Edison sought to portray AC as extremely dangerous, even going so far as to publicly electrocute animals with AC to show its dangers. Meanwhile, Tesla demonstrated the safety of AC by famously shooting current through his own body to produce light. This public feud culminated when Westinghouse, using Tesla's AC system, won the bid to electrify the 1893 World's Columbian Exposition in Chicago, proving that AC was a safe and efficient method for transmitting electricity over long distances. Later, they also won the contract to install the first power machinery at Niagara Falls, further establishing the dominance of AC power. Despite the rivalry, it's worth noting that Edison and Tesla were two very different inventors with different approaches to invention and innovation. Edison was more of a practical inventor who focused on commercial success, while Tesla was more interested in theoretical possibilities, many of which were not financially profitable. The so-called feud may have been more about their fundamentally different views on technology and business rather than personal animosity. In the late 1880s, George Westinghouse, the inventor and industrialist who founded the Westinghouse Electric and Manufacturing Company, became aware of Nikola Tesla's patents and work with alternating current, AC systems. Westinghouse was looking for a solution to supply the country with long-distance power, and he realized that Tesla's inventions could help him achieve this. In 1888, Westinghouse purchased Tesla's patents for the sum of $60,000, which included $5,000 in cash and 150 shares of stock in the Westinghouse Corporation. and also agreed to pay royalties of $2.50 per horsepower of electrical capacity sold. This partnership marked the beginning of the so-called War of the Currents between Westinghouse and Thomas Edison, who was a strong proponent of direct current, DC. Edison engaged in a public campaign to discredit AC, arguing that it was dangerous and could easily kill people, even going so far as to stage public electrocutions of animals to demonstrate his point. Tesla and Westinghouse, however, were undeterred. Tesla worked for many years at the Westinghouse Electric and Manufacturing Company in Pittsburgh, improving electrical devices and creating new ones. In the early 1890s, using Tesla's AC system, Westinghouse successfully bid to electrify the world's Columbian Exposition in Chicago, proving that AC was a safe and efficient method for transmitting electricity. The crowning achievement of Tesla and Westinghouse's partnership came in 1895 when they built a power plant at Niagara Falls that used Tesla's AC system to generate and transmit electricity to Buffalo, New York, marking the first time in history that an AC power station had transmitted electricity over such a long distance. However, the partnership faced significant financial difficulties. In order to keep his company afloat during an economic panic in the 1890s, Westinghouse explained to Tesla that the company would have to renegotiate their royalty agreement. Tesla, who was more interested in seeing his inventions come to fruition than in receiving personal gain, tore up the contract that had promised him significant royalties. This decision would cost Tesla millions of dollars in potential wealth, but saved Westinghouse's company from bankruptcy. Despite this setback, Tesla continued his work, and his AC system would eventually become the dominant method for generating and transmitting electricity, shaping the modern electricity infrastructure we know today. The partnership between Tesla and Westinghouse was a significant event in the history of technology, demonstrating the importance of collaboration and vision in the face of stiff competition and public scrutiny. Between 1887 and 1888, Nikola Tesla filed a series of patents that laid the foundation for the use of alternating current, AC, in modern electrical power systems. These patents were fundamental to the war of the currents between Tesla and Edison, with Tesla promoting AC and Edison promoting direct current, DC. Here are the key patents Tesla was granted in that time. Electromagnetic motor, U.S. patent 381,968. Granted May 1, 1888, this patent was for Tesla's invention of the AC induction motor. The motor used rotating magnetic fields to convert electrical energy into mechanical energy. The design remains widely used in industry today. Electrical transmission of power, U.S. patents 381,969 and 381,970. Also granted on May 1, 1888, these patents described methods and apparatus for the electrical transmission of power using alternating current. Electrical transformer or induction device, U.S. patents 382,279 to 382,282. Granted on May 1, 1888, these four patents provided designs for the Tesla Coil, which could raise or lower voltage levels and was a key component in transmitting and receiving wireless signals. System of electrical distribution, U.S. patent 390,413. Granted on October 2, 1888, this patent described a system for the distribution of electricity using alternating current. Method of and apparatus for electrical conversion and distribution, U.S. patent 390,721. Granted on October 9, 1888, this patent was for a dynamo electric machine, or a combination of machines that convert and distribute electrical energy. System of electrical distribution, U.S. patent 390,819. Granted on October 9, 1888, this patent also dealt with the distribution of electricity. Electromagnetic motor, U.S. patent 392,266. Granted on November 6, 1888, this patent was for a design of a direct current, DC motor, that employed the rotating magnetic field principle. Regulator for dynamo electric machines, U.S. patent 382,845. Granted on May 15, 1888, this patent was for a device that helped control the output voltage of a generator, improving the stability of the electrical power supply. Tesla's work during this period was instrumental in demonstrating the advantages of alternating current systems over direct current systems. This laid the groundwork for the modern electricity supply system and cemented Tesla's place as one of the most important inventors in the history of electrical engineering. The Tesla Coil, invented by Nikola Tesla in 1891, is an electrical resonant transformer circuit. It's designed to produce high-voltage, low-current, high-frequency alternating current electricity. The design consists of a primary coil and a secondary coil, each with its own capacitor, that are coupled together through mutual induction. A spark gap connects the two coils and also serves as a switch in the circuit. Here's a more detailed look at how a Tesla coil works. Primary circuit. The primary circuit includes a power source, a capacitor, a spark gap, and the primary coil. The power source provides electricity that charges the capacitor. Once the voltage across the spark gap is high enough, a spark jumps across it, causing the capacitor to discharge into the primary coil. Secondary circuit. The secondary circuit is made up of the secondary coil and sometimes a top load or terminal, a large, smooth-surfaced object, often a metal sphere or toroid, attached to the secondary coil's top end. The secondary coil is made up of many more turns of wire than the primary coil. When the primary circuit discharges, it creates a magnetic field around the primary coil, which then collapses quickly. This changing magnetic field induces a high-voltage, high-frequency current in the secondary coil. The top load or terminal prevents leakage of the coil's energy into the air and also helps to store energy to be released in the discharge. Discharge. The result is a dramatic display of sparks shooting out from the top of the secondary coil, creating an effect similar to artificial lightning. This is because the voltage generated is so high, often several million volts, that it causes the surrounding air to become ionized and conductive, allowing electricity to travel through it. While the Tesla coil is largely obsolete in practical electronics, it's still used in education to demonstrate principles of electromagnetism and resonance, and for entertainment in science museums and movies for its spectacular displays of sparks. It also laid the foundation for the invention of radio and TV transmission by demonstrating the principles of electromagnetic waves and wireless transmission. Tesla himself had larger aspirations for his coil. He believed it could be used to transmit both signals and power without wires. The largest implementation of his design was in his unfinished Wardenclyffe Tower project, which was intended for transatlantic wireless telephony and proof-of-concept demonstrations of global wireless power transmission. Nikola Tesla's wireless-controlled boat was one of the first demonstrations of wireless remote control. It was unveiled in 1898 at the electrical exhibition held at Madison Square Garden in New York City. Tesla had devised a system using radio waves to transmit signals, which he incorporated into a small model boat, making it respond to command signals from a remote control. The boat, approximately 4 feet long, was equipped with an antenna that received the radio signals. These signals were then interpreted by a mechanism inside the boat, which Tesla called a borrowed mind. This mechanism consisted of coiled-up springs connected to different rudders and propellers within the boat, allowing it to move in different directions and at different speeds in response to the signals it received. Using a box with switches and levers, Tesla was able to control the boat's movements in the water. The demonstration even included submerging the boat and having it resurface, as well as controlling the lights on the boat, all using radio signals. This boat was essentially a primitive form of a modern RC, remote control vehicle. Tesla filed a patent for this technology in 1898, titled Method of and Apparatus for Controlling Mechanism of Moving Vessels or Vehicles, U.S. Patent 613,809. This invention was a significant development in the field of radio and remote control. However, the potential military implications of this technology made some wary, as it hinted at the possibility of remote-controlled weapons. Tesla himself proposed the use of such technology for future warfare, envisioning unmanned, remote-controlled machines that could carry out tasks without putting human lives at risk. Nikola Tesla's later life was marked by financial struggles and increasing obscurity. After his most productive years in the late 19th and early 20th centuries, Tesla faced significant difficulties in securing funding for his projects. He became progressively more eccentric and reclusive, leading to public speculation about his mental health. Tesla continued to propose ambitious projects, even as his resources dwindled. In 1934, at the age of 78, he made headlines by announcing a death beam or peace ray that he claimed could end all war. He sought to interest the U.S. War Department, the United Kingdom, the Soviet Union, and Yugoslavia in his invention, but he was unable to secure significant funding. In 1935, Tesla claimed to have completed a dynamic theory of gravity, a unified field theory that he said would revolutionize physics and change human understanding of the fundamental forces of the universe. However, he never published it, and there is no evidence that he ever produced a workable model. Tesla lived out his final years in a series of hotel rooms in New York City, moving frequently and leaving unpaid bills in his wake. His last residence was room 3327 of the New Yorker Hotel. Despite his financial troubles, he maintained peculiar habits, such as requiring an unusually high number of napkins with every meal and feeding pigeons in local parks. Tesla died alone in his room at the New Yorker Hotel on January 7, 1943, at the age of 86. His body was found by a maid when she entered his room after he had failed to put out a "Do Not Disturb" sign for 2 days. The cause of death was coronary thrombosis. Following Tesla's death, representatives of the U.S. government's Office of Alien Property seized many of his personal belongings and notes. However, despite rumors of lost or suppressed inventions, most of Tesla's known work is now available in the public domain. Tesla's funeral took place on January 12, 1943, at the Cathedral of St. John the Divine in Manhattan, and he was cremated. His ashes were placed in a golden sphere, Tesla's favorite shape, which is now displayed in the Nikola Tesla Museum in Belgrade, Serbia. Despite his impoverished end, Tesla's scientific legacy continues to be felt in modern electrical systems and numerous technologies. Well, this was everything for today's video. Please consider subscribing, leaving a like, and commenting on the video since it helps the channel grow. Thank you for watching and see you next time.